In this video, I'm going to show you how to master parts per million and parts per billion calculations, and we are starting right now. Hello, this is Dr. Dankwa, and if this is your first time here and you like to learn pharmaceutical calculations, tips, tricks, and more, then start by subscribing and clicking the bell so you don't miss anything. So let's get right to it. There are two things we want to accomplish. The first is to be able to define and interpret what parts per million, which is PPM, and then parts per billion, which is PPB are, and then we'll go ahead and solve three strategically selected examples that illustrate the various ways in which you may encounter PPM calculations, and then we'll go ahead and do another three carefully selected examples of the various ways in which you may encounter PPB calculations. Before we delve deeper, let me give some brief context. Both PPM and PPB are part of the various ways in which you express concentration. The other two common ways would be ratio strength and percentage concentration. Now, I do have videos to these two topics, and I'm going to put links in the description, and the cards should be showing up pretty shortly. But PPM and PPB are often encountered in prescription writing and are particularly useful when you want to describe the concentration of very dilute preparation. So once again, why are there different ways of expressing concentration? That depends on the strength of the solution. So if you have a strong preparation, you normally will use percentage concentration. And if you have a weak preparation, you're going to use ratio strength. Now, when you have really dilute preparations, then you want to use the PPM and then PPB. And it's because of that you want to be masters of this type of calculation. So what we are going to do next is we're going to define what PPM is, and then we'll look at three examples of the various ways in which you may encounter PPM calculations. So when you talk about parts per million, which is PPM, you're actually referring to the number of parts of solute in a million parts of preparation. Now, the way you could capture this mathematically would be PPM is equal to parts of solute divided by a million parts of preparation. Now, PPM can also be expressed in different ways depending on whether you have a weight in volume, weight in weight, or volume in volume preparation. The first would be weight in volume. So if you have a weight in volume, then you can rewrite the original equation to be PPM being equal to the grams of solute in a million milliliters of solution. When you have your weight in weight, that will be PPM is now going to be equal to the grams of solute in a million grams of preparation. Now for the weight by weight or weight in weight, you could also have kilograms of solute in a million kilograms of preparation. The units must be consistent in the numerator as well as in the denominator. Now, if you have a volume in volume preparation, then it will be the milliliters of solute in a million milliliters of solution, or microliters of solute in a million microliters of solution. Here, the units in the numerator must be the same as the units in the denominator. So now let's go ahead and take a look at the first example. This question says if 14 liters of commercial ethyl alcohol are found to contain 0.01 milliliters of butanol, what is the concentration of butanol in ppm? So notice from the question that 0.01 milliliters compared to 14 liters is really minute, okay? And so this would be a good scenario where ppm would be a better way to capture the concentration. Now, the first thing we want to do is we want the units to be the same. No, this is a volume in volume preparation, and so we want the units in both the numerator and the denominator of our ratios to be the same. And so what we're going to do is we're going to convert the liters to milliliters and work in milliliters going forward. And the conversion factor is 1,000 milliliters make up 1 liter. So now the first thing we want to do is convert the 14 liters to milliliters. So we have our ratio, which says 1,000 ml divided by 1 liter, now being equal to x milliliters over 14 liters. That becomes our proportion. So we go ahead and solve for our unknown, which is x. So x is going to be equal to 14 liters times 1,000 milliliters divided by 1 liter, and that gives us 14,000 milliliters. So now we know that we have 0.01 milliliters of butanol in 14,000 milliliters of commercial ethyl alcohol. We can go ahead and set up a new proportion, and what that would look like would be the 0.01 milliliters of butanol divided by 14,000 milliliters of ethyl alcohol being equal to some quantity in milliliters divided by 1,000,000 milliliters of the preparation. So when we solve for y, that will give us the amount of solute in milliliters of butanol that will be present in 1,000,000 milliliters of ethyl alcohol, and that will be the same as the ppm. So what that will look like is you now have y being equal to 0.01 milliliters times 1,000,000 milliliters divided by 14,000 milliliters. That gives us 0.71 milliliters, and so the answer to the question will be 0.71 ppm. Let's take a look at the next example. This question says a sample of a solution for injection is found to contain 1.4 ppm of lead chloride. How much of the solution will contain 50 micrograms of lead chloride? So if we were to analyze the question, what we've been given is the concentration of lead chloride in ppm parts per million. We know that we have 50 micrograms of lead chloride, and we want to determine the total volume of preparation that would allow us to make. So this is a weight and volume scenario, and so ppm will be the grams of solute in 1,000,000 milliliters of solution. So we want to go ahead and convert the 50 micrograms to grams before we proceed. And so the conversion factor here is 1,000,000 micrograms is present in 1 gram. So we go ahead and convert the 50 micrograms to grams using the conversion factor, where you have 1,000,000 micrograms divided by 1 gram being equal to 50 micrograms divided by x grams. We go ahead and solve for x. X is going to be equal to 50 micrograms times 1 gram divided by 1,000,000 micrograms, and that will give you 5 times 10 to the negative 5 grams. Alright, so now we have the amount of lead chloride in grams. We go ahead and set up the proportion, taking the 1.4 ppm. So 1.4 ppm will be 1.4 grams of lead chloride in 1,000,000 milliliters of solution. And that's going to be equal to the 5 times 10 to the negative 5 grams of lead chloride divided by some given volume, which you do not know. So we can go ahead and solve for y, which is our unknown here, and y will be equal to 5 times 10 to the negative 5 grams times 1,000,000 milliliters divided by the 1.4 grams, and we end up having 35.71 milliliters. And so the answer to this question will be 35.71 milliliters. Let's take a look at the next question for parts per million, which says calculate the concentration of phosphates in ppm if a sample of tap water weighing 10 grams contains 5.9 times 10 to the negative 5 parts of phosphates. So in this question, our goal is to determine ppm. We have 10 grams of water, and so the parts, the 5.9 times 10 to the negative parts of phosphate would also refer to grams. And so the first thing we want to do is set up a proportion. So we have 5.9 times 10 to the negative 5 grams divided by the 10 grams being equal to x grams over 1,000,000 grams, which would be the definition of ppm for a weight in weight scenario. So we go ahead and solve for x. X is going to be equal to 5.9 times 10 to the negative 5 grams times 1,000,000 grams divided by the 10 grams, and that should give us 5.9 grams. And so the answer to the question is 5.9 ppm. So we've just taken a look at 3 carefully selected examples that illustrate different ways in which you may be required to do ppm calculations. So now let's take a look at parts per billion calculations. Parts per billion, which is ppb, describes the number of parts of solute in a billion parts of preparation. That will be 10 to the power 9. And so mathematically, this can be captured as ppb being equal to parts of solute divided by a billion parts of preparation. Now this can also be expressed in 3 different ways depending on whether you have a weight and volume scenario, a volume in volume, or a weight and weight situation. So for a weight and volume scenario, PPB is going to be equal to grams of solute in a billion milliliters of solution. Then when you have a weight and weight scenario, PPB is going to be equal to grams of solute over a billion grams of preparation. And then for a volume in volume situation, PPB is the milliliters of solute in a billion milliliters of solution. So let's take a look at this question, which says that drinking water in a remote desert area contains 0.34 ppb of selenium. How many micrograms of selenium will be ingested by a camel whose water intake is 110 liters? Now, if you take a look at this question, this is a weight and volume kind of scenario. And so by definition, ppb is the grams of solute in a billion milliliters of solution. And so we want to first convert the 110 liters to milliliters, and the conversion factor here will be 1000 milliliters is contained in 1 liter. So if you want to convert 110 liters to milliliters, you have 1000 milliliters divided by 1 liter being equal to x milliliters over 110 liters. Go ahead and solve for x, which is our unknown. X is going to be equal to 110 liters times 1000 milliliters divided by 1 liter, and that gives us 110 milliliters. So now we go ahead and set up a proportion. 0.34 ppb is going to be the same as 0.34 grams divided by a billion milliliters, and so that should be equal to our unknown, which is y in grams, divided by 110 milliliters, which is the volume the camel ingested. So you go ahead and solve for y. Y is equal to 0.34 grams times 110,000 milliliters divided by a billion milliliters, and that is equal to 3.74 times 10 to the negative 5 grams. But we don't stop here because the question is asking for how many micrograms. And so the next thing we want to do is convert the grams to micrograms, and a million micrograms is present in 1 gram. So we go ahead and set up a proportion using the conversion factor. A million micrograms is divided by 1 gram, and that is equal to x micrograms divided by the 3.74 times 10 to the negative 5 grams. We go ahead and solve for x. So x is equal to 3.74 times 10 to the negative 5 grams times a million micrograms divided by 1 gram, and that gives us 37.4 micrograms. And so the answer is going to be 37.4 micrograms. Let's take a look at another question which says the asbestos level of a talc deposit is 0.79 ppb. How many micrograms of asbestos would be found in 10 grams of this talc? Now the first thing we want to do is take the definition of ppb. Now this is a weight and weight situation, and so 0.9 ppb will be 0.79 grams of asbestos in a billion grams of talc, and that should be equal to some quantity in grams, in this case x, divided by the 10 grams of talc that we are interested in. So we go ahead and solve for x, which is our unknown. X is equal to 0.79 grams times 10 grams divided by a billion grams, and that is equal to 7.9 times 10 to the negative 9 grams. But we don't stop here because the question is asking for the quantity in micrograms. So we go ahead and do another conversion, making use of the conversion factor that a million micrograms is contained in 1 gram. We set up another proportion where a million micrograms is divided by 1 gram, and that should be equal to our unknown, which is x micrograms divided by 7.9 times 10 to the negative 9 grams. So we go ahead and solve for x, which is our unknown. X equals 7.9 times 10 to the negative 9 grams times a million micrograms divided by 1 gram, and that will be equal to 0.0079 micrograms. And so the answer to this question is 0.0079 micrograms. Let's take a look at another question. This question says calculate the concentration of sulfates in ppb when 1,000 parts of water contains 10 to the negative 7 parts of sulfates. So here you have a weight and volume situation, and so your ppb will be the grams of solute divided by 1 billion parts of solution. And so we can go ahead and set up a proportion. We have 1 times 10 to the negative 7 grams of sulfates in 1,000 milliliters of water. And so we need to figure out how many grams of sulfate will be present in 1 billion milliliters of water. We go ahead and solve for x, which is our unknown. So x equals 1 times 10 to the negative 7 grams times 1 billion milliliters divided by 1,000 milliliters. And that is going to be equal to 0.1 grams. And so the answer to this question is 0.1 ppb. So I hope you found this tutorial on PPM and PPB calculations useful. If you did, be sure to like and share the video. And if you would like to learn more pharmaceutical calculations, tips, tricks, and strategies, please subscribe so you don't miss anything. If you have any questions, also put them in the comments and I will be sure to address them as soon as I see them. Thank you so much for watching. Enjoy your life and I will see you in the next video.